All right, this video is going to talk a little bit about how we use binomial probability distributions. Again, if you're unfamiliar with binomial probabilities, make sure you watch my other video describing sort of where they come from. But this video is mostly just going to talk about a few different examples of sort of how to interpret questions. So we first have a question about spinors. Again, spinors are a great example of independent ideas. What you spin the first time in no way should affect, right, what happens the second time. So if we're talking about the probability that you spin 2 squares out of 3 spins on this first spinner, let's go ahead and set up, again, the probability that r equals 2, or we're going to have 2 successes. So again, there are 3 spins. We're going to have 2 successful ones. The probability of getting a square appears to be 1 out of 4, right? There's 4 possibilities, and the probability is 1 out of 4. Again, we're going to have 2 of those happen. But again, the probability of failure then is 3/4, right? 3 out of the 4 things are things we don't want. And again, we want that to happen once. We need 3 total spins, right? 2 success, 1 failure. And again, there are 3 choose 2 ways for that to happen. That failure could happen either first, second, or third, right, on those spins. So we need to consider all those ways. If you calculate those numbers and you figure it out, basically you'll find out that's 0.141 approximately for a final answer. Again, feel free to pause the video and try the other 2 if you'd like to before we sort of get them set up. Otherwise, let's go ahead and set them up. The probability this time of getting 4 B's in 7 spins, well, is the probability again of 4 successes. We'll call B's success. And so therefore we're going to say 7 spins. We're going to calculate 4 successful ones. It appears that there's a 1/3 chance of spinning a B, right? It looks to be about 1/3 of the circle. Again, that's going to happen 4 times. And there is a 2/3 chance of not a B. Again, I'm not worried about A and C separately. I just know there's a 2/3 chance of not B, right? Of not B. So again, there are 3 of those that need to happen if we're doing 7 total spins. 4 success, 3 failure. And again, if you calculate those numbers and multiply it all out, should be 1 or 0.128. Right? There's our probability written as a decimal there. Final scenario, again, we've got a spinner over here with 5 possibilities, but what's the probability you get 6 X's, right? The probability of all 6 of them in 6 spins. So the probability of r equals 6. Well, in 6 spins, we're going to have 6 successful. It appears there's a 1/5 chance of getting an X. Again, it needs to happen all 6 times. And there is a 4/5 chance of not getting an X. But again, we don't want that to happen at all, right? 0, 6 minus 6 being 0 chances of that. Technically, this one wouldn't need to be a monstrous binomial problem. 6c6 is 1, 4/5 to the 0 is 1, and really you end up only really needing to find what's 1/5 to the 6th power, right? If they're all going to be successes, right? We only really need to worry about that. There's only one way that can happen, so we don't have to get too fancy there. But it's never a bad idea to set the whole thing up. Again, your probability there is pretty small. It actually comes out to 2.14 times 10 to the negative 5th, or written as a decimal, 0.00214 here, approximately. And it's never a bad idea. Don't round off too much when you do that. If you round to 3 decimal places, it looks like that can't happen. But technically it can. So you make sure you want to note that, yep, 0.0000, but hey, 214, there is a chance, right? There is a chance that happens. Let's look at one more scenario. Let's say you were planting pumpkin seeds, right? You wanted to grow some pumpkins. Each seed has about a 70% chance of maturing into a healthy plant. So you bought some seeds, whether or not you thought a 70% chance was a pretty good one or not. What's the probability you get exactly 3 healthy plants? Again, you don't expect them all to grow, but what's the chances out of 5 seeds you get 3 good healthy plants? Well, again, we've got 5 seeds possible. We want 3 of them to grow, right? 3 is going to be our success. So again, 3 was R, right? Whereas N, right, the total number of seeds was 5. We're going to multiply that by the probability of success. Again, we call that P. Whereas the probability of failure, Q equals 1 minus P, is going to be 0.3. So 0.7, we're going to have 3 successful plants. And 0.3, we're going to have 2 not successful plants. Right? If you multiply all that out, again, your probability is 0.3087. So just a little over 3/10 of a chance, right, of 3 successful plants out of 5 there. Now, we'd probably be pretty happy with 3 successful, but what about 4 or 5, right? If we want at least 3, there's a little different scenario there. Now we have to say, well, hey, we want 5C3, right? 3 successes with 2 failures, or we could have 4 successful, right? Then we have at least 3. Nothing wrong with a little extra success. So we want 4 successful, again, assuming 1 fails. Or, hey, maybe the slight scenario of maybe we get all 5 successful plants. Then we've got at least 3, right? That's a good thing. And if you add all of those scenarios up, right, you got to find all 3 of those separately. Again, probably have 3 success and 2 failure, or, right, or means add. 4 successes, 1 failure, 5 successes, and no failures. All together, right, you might not have thought that 0.318 or 3087 was a real good chance that this was going to happen, but 3 or more successes, right, at least 3 successes, there's actually 0.83692. I didn't even round off for you there. So a little over an 83% chance, right, that you're going to have at least 3 successful. So that's not a bad thing. I hope that helps you again, seeing a couple of examples of binomials. If you have any questions, make sure you talk to your teacher, and have a great day.